In this lesson, we are going to solve equations that can be written in a quadratic form. Quadratic forms, again, are trinomials involving ax squared plus bx plus c. And to solve such equations, we need this very important property, which is called the zero product property. What it says, if you have the product of two things equal to 0, then either one of the factors are 0. Think about it. If you have a zero product, then either A is 0, because if A is 0, then you get 0 times B, and that's equal to 0. The equation checks out. Or if B is 0, then whatever A is multiplied by 0, that gives you 0. That also checks out. Now, this property will not work if you have a number other than 0 on the right hand side. So, for example, if I have 1, you can't say A is 1 or B is equal to 1. A lot of people, when they solve a quadratic equation, they do not set it equal to 0. And that way they don't get the right answer. Let's look at some examples. Here we have a quadratic equation. It's an equation, it's not an expression. If this was an expression, then it would not have the equal sign. So we want the solution or solutions to this equation. A solution is a number x that is going to make this equation true upon plugging x into this equation. To solve this equation, we need to use the zero product property, meaning that we need to move all the terms to one side of the equation. So we're going to move 77 to the left hand side of the equation. It becomes negative 77. On the right hand, you should have 0. Then, as the zero product property suggests, we have to have factors. So if you have a quadratic or any polynomial that is factored out, we've had a lesson on factorization. When the leading coefficient is 1, you're going to look for two numbers that will multiply to negative 77, and when added, they add up to the middle coefficient of 4. 77 doesn't have too many factors, only 7 and 11. So let's try them out. 11 and 7, one of them should be negative because the product is negative 77. We want the sum to add up to 4. So in this case, 7 should be negative. 11 times negative 7 is negative 77, and 11 plus negative 7 is 4. Now we can write the quadratic expression on the left as a product of x plus 11 and x minus 7. On the right hand, we have 0. Now this is as if we have a times b equal to 0. Again, by the zero product property, you set each factor equal to 0. So here we have x plus 11 equal to 0, or x minus 7 equal to 0. You can solve each equation for x. For the first one, we subtract 11 x's equal -11, which is one of the solutions, and the other solution can be obtained by adding 7 to the right hand side. So solutions to this equation are -11 and 7. You can check by plugging each solution back to the equation to see if each solution makes the equation true. Let's look at the next example, which sometimes some might find a little bit tricky. I want to go over what not to do with this equation. We have on the left 4x cubed, on the right we have 64x, and people think that since this is an equation, we can do whatever we want to both sides. We can add, we can subtract a number to both sides, we can divide or multiply both sides by a number, and to many, x appears on the left and the right, so they think that they can begin by dividing the left and right of the equation by x. And that results in a new equation, which is 4x squared equal to 64. If you notice that the original equation is true when x is 0. If you put 0 for x on the left, you get 0. On the right, you get 0. So 0 equals 0. That means x of 0 makes the equation true. But when you rewrite the equation this way by dividing by x, we no longer have x as a solution to this equation. As a matter of fact, the exponent went from 3 to 2. Instead of expecting 3 or less solutions, we now expect 2 or less solutions, which is not true. Remember that we can never divide by x. Never divide an equation by the unknown, in this case x. You can divide an equation by a non-zero number. Like for instance, I can divide left and right of this equation by 4 because both left and right are in fact divisible by 4, but I definitely can't divide by x. Let's try to solve this equation properly. We're going to, as before, move all terms to one side of the equation. I'm gonna subtract 64x and rewrite as 4x cubed minus 64x equal to 0. Remember, with nonlinear equations, you always want to have 0 on the right hand side so that we can use the zero product property. Next is to factor out the equation. We always look for the GCF of the expression in the equation. We have 4 and 64. They have a GCF of 4, and x cubed and x, they have GCF of x. Again, remember x to the smallest exponent, x cubed and x, that would be x. And that leaves us with 4x squared out, we get x squared minus 16. Because 64x divided by 4x is 16. We are not done yet. We have a quadratic here. This is a difference of two squares that can be factored out. And here we identify a with x, and since b squared is 16, we identify b with 4. So here we have, for a, we have x, and we'll just use one color here. For a, we have x. For b, we have 4. So x plus 4 and minus 4 are the factors of the difference of two squares. As you see, we have 1, 2, 3 factors. You might say we have 4 factors because of that constant, but this 4 does not give you a solution. Set each of these factors equal to 0. We have 4x equal to 0. We have x plus 4 equal to 0. And again, this is by the zero product property. X minus 4 equal to 0. Then solve each equation individually. For the first one, 4 times 0 is 0, so x is 0. For the second one, we subtract 4. X is equal to -4, or you can just think of a number so that when you add 4 to it, you get 0. That number is -4. And for the third equation, x should equal to 4. We have 3 solutions: 0, -4, or 4. Example 3 is not directly a quadratic. First of all, let's look at it. We have 3 terms, but the degree of this equation is not 2. But what I've done, since this equation is nonlinear, is to move the 2 terms on the right to the left hand. So I added 6 root x and I subtracted 9. But what we need to do is we need to write this trinomial in quadratic form. Notice that if I let u equal to root x, then we know that if I square u, I get x. Therefore, this x can be think of as u squared. Therefore, we have 8u squared plus 6 root x is called u minus 9 equal to 0. Now we have to solve this quadratic equation. This is a quadratic equation whose leading coefficient is not 1. Therefore, we have to multiply the leading and the constant. That gives us -72. Therefore, we look for 2 numbers that multiply to -72, and when added, they add up to the middle coefficient of 6. This might require a little bit of thinking, but 72 has factors of, let's see here, 12 and 6. 12 times 6 is 72. We want one of them to be negative. We want 6 to be negative because 12 plus a -6 is 6. Now we can rewrite the middle term using these coefficients. We have 8u squared minus 6u plus 12u minus 9 equal to 0. And again, it doesn't matter if I write 12u and then minus 6u. The factorization is still going to work. Now we have groups of 2. From each group, you take out the GCF. From the first group, we can take out the GCF of 2u. That is going to leave us with 4u minus 3. And from the second group, 12 and 9 have a GCF of 3. We can take that out, and that leaves us with 12u divided by 3 is 4u. Negative 9 divided by 3 is negative 3. Notice that these two must match. If they don't match, then the problem is not factorable, or something has gone wrong in our factorization. Now, take out the common. The common is what I have written in red. 4u minus 3 can be taken out. With that taken out, we are left with 2u and positive 3. And don't forget that this is an equation. We're setting it equal to 0. Now solve each equation. We have 4u minus 3 equal to 0, or 2u plus 3 equal to 0. Now the first equation gives us u equal to 3/4. The second one gives us u equal to negative 3/2. But now you gotta keep in mind that it is not u that we are trying to solve. It is x. Square root of x has been replaced with u. So for the first one, let's call this number 1. And we're going to call this number 2. For the first one, replace u with root of x. Root of x equal to 3/4. To get x, simply square. To get rid of the square root, x is going to give you 3 squared, which is 9/4 squared. That is 16. Looking at the second equation, we have u, which is originally root x, equal to negative 3/2. And one thing we know about square roots is that there's no real number whose square root is negative. So the second equation is not going to give you a solution. As a matter of fact, the only solution is x equal to 9/16. Just remember that the range of a square root is always non-negative. A square root can't give you a negative value. Let's look at the fourth example. Here we have an equation that involves 3 terms. And once again, just like the previous equation, I am going to move the 18x to the left and set equal to 0 to get 8x to the 5 minus 10x cubed minus 18x equal to 0. We ultimately have to use the zero product property. Second step is to look at this trinomial and identify the GCF. Well, we have 8, 10, 18. They all have a GCF of 2. X to the 5, x cubed x have GCF of x. The GCF is 2x, leaving us with 4x to the power of 4 minus 5x squared minus 9. And again, on the right hand, we have 0. But here we still don't have a trinomial that is quadratic because the degree is 4. But we can still factor this trinomial the way we factored out other quadratics. We are going to multiply the leading coefficient with the constant. 4 times negative 9 is negative 36. Therefore, we look for two numbers that multiply to negative 36 and at the same time add up to the middle coefficient of negative 5. Factors of 36 are 9 and 4. 9 times 4 is 36. One of them has to be negative. Since we have a negative 5 as a sum, we want 9 to be a negative. Negative 9 plus 4 is negative 5. So we're going to carry down the GCF and open a bracket, or you can open parentheses. Leave the leading term alone, and the middle term can be written using the two numbers that we just found. We have negative 9x squared plus 4x. We're gonna leave the constant alone, close the bracket, set it equal to 0. Once again, we have 4 terms. Group 2 by 2. From each group, take out the GCF. Don't forget to carry down the original GCF bracket. From the first group, we have coefficients 4 and 9. They have no common factor. But x to the 4 and x squared have a common factor of x squared. We'll take that out. That leaves us with 4x squared minus 9. And from the second group, we have 4 and 9 they have no GCF. Therefore, we're just going to leave that alone. So we can write plus, you can write a 1, and write down 4x squared minus 9. Close the bracket, set equal to 0. Next step, carry down the original GCF. From the two groups, we can take out the 4x squared minus 9. To see what stays, open parentheses, cover that 4x squared minus 9, we're left with x squared. And from the second group, if you cover 4x squared minus 9, we are left with plus 1. And again, I can drop the bracket because I have a series of multiplications. They're all factors. Now notice that The expression inside the red parentheses consists of a difference of two squares, which can be factored out. We're going to factor out the polynomial as much as we can. 4x squared minus 9 is a difference of two squares that can be written as 2x plus 3, 2x minus 3. X squared plus 1 is the sum of two squares that is not factorable. Now we are ready to solve the equation. Obtain every solution by setting each factor equal to 0. We have 2x equal to 0, which results in x equal to 0. We have 2x plus 3 equal to 0. If you move the 3 over, you get negative 3, and divide by 2, that gives you x equal to negative 3 half. And the third factor is 2x minus 3. Set that equal to 0 by the zero product property. If I move the negative 3 over, it becomes 3. Then divide by the coefficient of x, we get x equal to 3 half. And finally, we have the factor x squared plus 1. That's a sum of two squares. Sum of two squares is never equal to 0 because we are adding a square which is never negative. Any positive or negative number squared results in a positive. When you add 1 to that, the result will never be 0. So our solutions are x equal to 0, x equal to negative 3 half, and x equal to 3 half